Hi children, very good morning each and everyone. Dear children, let us continue the class. Here we have find the unit vector in the direction of the vector PQ where OB bar is equals to 2i minus j plus k and OQ bar is equal to 3i minus 4j plus 2k. We have to find the unit vector in the direction of this vector given its position vectors. We know that the vector PQ bar can be expressed in terms of its position vectors, that is OQ bar minus we have OP bar. Again that is equal to, what is OQ bar? This. So this minus this, that is subtracting the corresponding components. So 3 minus 2 we have I. Again so minus 4, here we have minus 1. Minus of minus, it becomes plus, therefore we have minus 3j. Children, minus 4 minus of minus becomes plus, minus 4 plus 1 we have minus 3j. Again so 2 minus 1 we have 1k, that is plus k. Okay, so now we have to find the unit vector in the direction of this vector. We know to find any unit vector we have to find the magnitude of that vector. So therefore again I will find the magnitude of this. So therefore magnitude of PQ bar is equal to square root of, we have x value, that is 1 square 1 plus minus 3 whole square we have 9. Again plus 1 square we have 1. Again that is equal to square root of 11. So now we need to find unit vector. Therefore unit vector n cap, or you can write PQ bar cap. N cap is equal to, that is PQ bar divided by magnitude of PQ bar. Okay, again that is equal to, what is PQ bar? We have I minus 3j plus k whole divided by, we have that is root 11, or this can be written as, that is equals to, we have 1 divided by, so 1 divided by root 11 into I. Again minus 3 divided by root 11 into j. Again plus we have 1 divided by root 11 into k. So this is the unit vector in the direction of the vector PQ. Next, find the vector in the direction of the vector A bar is equals to I minus 2j, which has a magnitude of 7 units. So we need to find vector. So for that we need to find first a unit vector. Here given A bar is equals to I minus 2j. We know how to find a unit vector. So that is A cap is equals to A bar divided by magnitude of A bar. Okay, here we need to find magnitude of A bar. Therefore magnitude of vector A is equals to square root of x square, that is 1 square 1 plus minus 2 whole square we have 4. Again that is equals to, we have root 5. Therefore what is A cap? Therefore A cap is equals to value of A bar we have, that is I minus 2j whole divided by, we have root 5. Again that is equals to 1 divided by root 5 into I minus 2 divided by root 5 into j. Okay, so this is a unit vector. So we need to find a vector. Therefore multiply the unit vector by 7. So therefore that is the required vector. Okay, required vector is, okay, that is 7 into unit vector, that is equal to multiply 7 to each component. Therefore that is 7 into 1, we have 7 divided by root 5 into I minus 7 into 2 we have 14. 14 divided by root 5 into j. So this is a vector in the direction of a bar. Next, similar question we have, find the vector in the direction of the vector 5i minus j plus 2k which has a magnitude of 8 units. So here similarly we have to find first a unit vector. Given vector A is equals to 5i minus j plus 2k plus 2k. So magnitude of A bar is equals to square root of 5 square we have 25 minus 1 whole square we have 1 plus 2 square we have 4, again that is equal to root 30. So we need to find n cap or a cap. Therefore a cap is equals to, that is unit vector, is equals to A bar divided by magnitude of A bar. Again that is equals to, what is A bar? We have that is 5i minus j plus 2k whole divided by, we have magnitude of A bar, that is root 30, or that can be written as 5 divided by root 30 I minus 1 divided by root 30 j plus 2 divided by root 30 into k. So this is unit vector, but we need to find vector. Now multiply this unit vector by given units. Okay, therefore the required vector is, that is 8 into a cap. Just multiply this entire vector, that is multiplying the scalar component of this vector by a given unit, that is 8. Therefore that is equals to, we have here 8 into 5, that is 40. So 40 divided by root 30 into I minus 1 into 8, we have 8. So that is 8 divided by root 30 into j. Again we have plus 8 into 2, we have 16, that is 16 divided by root 30 into k. So this is a vector in the direction of a given vector. Next, find the vector in the direction of the vector 2i minus 3j plus 4k which has a magnitude of 5 units. Similar question. So given A bar is equals to, we have 2i minus 3j plus 4k. So magnitude of A bar is equal to square root of 2 square, we have 4 plus minus 3 square, we have 9 plus 4 square, we have 16. Okay, again that is equal to 16 plus 4, 20 plus 9, that is 29. Again therefore a cap is equals to A bar divided by magnitude of A bar. So this is the formula to find a unit vector in the direction of a given vector. Again that is equals to A bar, we have 2 divided by root 29 into I, again minus 3 divided by root 29 into j, again plus 4 divided by root 29 into k. Have written directly. Okay, this is a cap, but we need to find vector in the direction of given vector. So again multiply the unit vector by given units. Therefore required vector is, that is 5 into a cap, that is equal to, multiply 5 to each scalar component of this unit vector, that is 5 into 2, we have 10 divided by root 29 into I minus 5 into 3, we have 15 divided by root 29 into j, we have plus 4 into 5, that is 20 divided by root 29 into Okay, so this is the vector in the direction of this vector having a magnitude 5 units. Find the direction ratios and direction cosines of the vector I plus 2j plus 3k. Here given that is vector A is equals to I plus 2j plus 3k. So now we have to find the direction ratios and direction cosines of this vector. So usually the scalar components of a vector are direction ratios. Direction ratios. The scalar components of the given vector are direction ratios. Here what is the scalar component of vector? That is 1 comma 2 comma 3, right? Therefore direction ratios, so that is direction ratios are simply write d r apostrophe s r. We have 1 comma 2 comma 3. Okay, then we have to find direction cosines. Direction cosines, we know how to find direction cosines. Usually L, M, N are called as direction cosines. We have that is L is equals to, we have that is x divided by magnitude of a bar. Again we have M is equal to y divided by magnitude of a bar, and n is equals to magnitude of n is equals to z divided by magnitude of a bar, right? So L, M, N are called as direction cosines, which are given by x divided by magnitude of a bar, m is equal to y divided by magnitude of a bar, n is equals to z divided by magnitude of a bar. Again, so we need to find magnitude of a bar. Therefore magnitude of a bar, that is magnitude of a bar is equal to square root of, we have formula, that is x square plus y square plus z square, right? Again that is equal to square root of, what is the value of x here? 1 whole square we have 1 plus y value 2 square we have 4, again plus magnitude of so that is z 3 square we have 9, again that is equals to 9 plus 1 10 plus 4, that is root 14. Okay, so therefore what is L is equal to x. What is the value of x here? That is 1, that is equals to 1 divided by root 14. Again that is equals to, we have 2 divided by root 14, and n is equals to, we have z. What is the value of z? That is 3 divided by root 14. Therefore remember the formulas. L, M, N are called as direction cosines, given by L is equal to x divided by magnitude of a bar, M is equal to y divided by magnitude of a bar, and n is equals to z divided by magnitude of a bar. Therefore 1 by root 14 comma 2 by root 14 comma 3 by root 14 are direction cosines of the given vector. Next, find the direction cosines of the vector. Number 1, 2i plus 3j plus k. Number 2, 2i plus j minus 2k. So we have to find the direction cosines. I already told you that L comma M comma N are called as what? Direction cosines of a vector. We have formula L is equals to x divided by magnitude of a bar, M is equals to y divided by magnitude of a bar, comma n is equal to z divided by magnitude of a bar, right? You should remember this. Okay, so L comma M comma N are direction cosines. Okay, first one. So write the given vector as vector A. Therefore vector A is equals to 2i plus 3j plus k, right? So now we need to find L, M, N. Therefore I'll find first magnitude of a bar. Magnitude of a bar is equals to square root of 2 square we have 4 plus 3 square we have 9 plus 1 square we have 1, that is equal to root 14. Therefore L, what is L? L is equals to x divided by magnitude of a bar. Again that is equal to, what is x value? 2. That is 2 divided by root 14. Again m. So that is m is equals to y divided by magnitude of a bar. Again that is equals to y. That is 3 divided by magnitude of a bar. We have root 14. Root 14. Again n is equals to z divided by magnitude of a bar. Magnitude of a bar, that is equal to z. We have 1 divided by square root of 14. Okay, therefore 2 by root 14 comma 3 by root 14 comma 1 by root 14 are direction cosines of this vector. Similarly we have a second vector. So write this vector as a, therefore number 2, a bar is equals to, we have 2i plus j minus 2k minus 2k. So again magnitude of a bar is equal to square root of 2 square 4 plus 1 square 1 plus minus 2 whole square, we have 4. Again that is equal to root 9, that is equals to 3. Okay, so now what is L? L is equals to, we have x divided by magnitude of a bar. Again that is equals to, what is x value here? That is we have 2. 2 divided by magnitude of a bar, we have that is 3. Again m is equals to y divided by magnitude of a bar. Again that is equal to, what is the y value? We have 1 divided by magnitude of a bar, we have 3. 1 by 3. Again n is equals to z divided by magnitude of a bar. What is the value of z? minus 2 whole divided by magnitude of a bar, we have 3. Okay, therefore 2 by 3 comma 1 by 3 comma minus 2 by 3 are direction cosines of the given vector. Next, find the direction cosines of the vector joining the points a of 1 comma 2 comma minus 3 and b of minus 1 comma minus 2 comma 1 directed from a to b. So remember, directed from a to b, the direction is towards b from a. So we have to find first what? AB bar. So therefore given, that is given points, that is this can be written as what? OA bar. OA bar is equals to, that is 1 comma 2 comma minus 3. Similarly OB bar is equals to minus 1 comma minus 2 comma 1. Remember, this can be written in terms of vector or points. Okay, or this can be written as what? OA bar is equals to 1 into I again plus 2 into j, we have 2j. Again minus 3 into k, we have minus 3k. Similarly OB bar is equals to minus 1 into I minus 2 into j minus 2j, 1 into k, we have k. One and all same. Okay, we will write in terms of points. Okay, next here we need to find AB bar. So therefore AB bar is equals to, expressing this in terms of its position vectors. So OB bar minus OA bar. Again that is equal to this minus this. Okay, so minus 1 we have minus 2. Again minus 2 we have minus 2, we have comma minus 4. Again comma 1 minus of minus 3, we have plus 3. 1 plus 3, we have 4. Okay, right? So now we have to find the direction cosines of this vector. So we know that this can be written as, so that is AB bar is equals to minus 2i minus 4j plus 4k plus 4k. One and all same. So we know, we need to find the direction cosines, we need to find magnitude of a vector. Therefore magnitude of AB bar is equal to square root of minus 2 whole square, we have 4 plus minus 4 whole square we have 16. Again plus 4 whole square we have 16, right? Again that is equal to square root of 14 plus 16 plus 4 20, 20 plus 16 we have 36. What is square root of 36? That is equal to 6. Okay, next we need to find direction cosines which are given by L, M and N. Okay, therefore we have L is equals to, we have x divided by magnitude of here AB bar, magnitude of AB bar. Again that is equals to, here we have what is the value of x? Minus 2. That is minus 2 divided by, we have 6. Again that is equals to 2 ones are 2 3s are, so that is minus 1 divided by 3. Again we have M is equals to y divided by magnitude of AB bar. Again that is equals to, what is the value of I here? We have minus 4. Minus 4 divided by magnitude of AB bar, we have 6. Okay, again that is equals to 2 2s are 2 3s are, so that is 2 divided by minus 2 divided by 3. Again N is equals to, we have z divided by magnitude of AB bar, magnitude of AB bar. Again that is equal to, we have 4 divided by 6, that is equal to 2 divided by 3. Therefore minus 1 by 3 comma minus 2 by 3 comma 2 by 3 are direction cosines of the line joining A and B, directed from A to B. You should remember this is the most new, directed from where to where? A to B is important. If he has given B to A, then this would be vector B A bar, right? You should remember this. Next, find the direction cosines of the line whose direction ratios are 2 comma minus 1 comma 2. So it has given direction ratios. So then we need to find direction cosines. So what are direction cosines? That is we have L comma M comma N. Okay. So to find that we need to find what? Magnitude of A bar. Okay. So let's A bar is equals to, alright, 2 comma minus 1 comma minus 2. So these are called as what? Direction ratios. Okay, so therefore we need to find magnitude of A bar. Magnitude of A bar is equals to, we have square root of 2 square 4 minus 1 square we have 1 plus minus 2 whole square we have 4. Again that is equal to root 9, that is equals to, we have 3. Okay, therefore L is equals to x divided by magnitude of A bar, that is 2 by 3. Then M is equals to minus 1 divided by 3 and N is equals to minus 2 divided by 3. We have formula L is equal to x divided by magnitude of A bar. Again M is equal to y divided by magnitude of A bar, and N is equal to z divided by magnitude of A bar. Okay, how written directly. Next, show that the points with the position vectors 7i plus 10k, comma minus I plus 6j plus 6k and minus 4i plus 9j plus 6k forms the vertices of a right angle triangle. Vertices of a right angle triangle. We know that what are vertices? So this are called as what? Vertices of a triangle. To prove that it is a right angle triangle, the one angle of a triangle must be 90 degree. If one angle of a triangle is 90 degree, then we say that it is a right angle triangle. For example, now it is a right angle triangle. Okay. If all the sides of a triangle are equal, then we say that such a triangle is called as equilateral triangle. Again, if any two sides of a triangle, either this and this or this and this or this and this, if any two sides of a triangle are same, then we call it as isosceles triangle. Remember this. If all the sides of a triangle are same, then we say it is equal to triangle. If two sides of a triangle are same, then we say it is a isosceles triangle. If any one angle in a triangle is 90 degree, then we say it is a right angle triangle. To prove that it is a right angle triangle, we have two methods. One, show that it is a one angle of a triangle is 90 degree. Other method is sum of squares of two sides. Sum of squares of two sides is equal to square of hypotenuse side. Square of hypotenuse side. For example, A, B, C. We have to show that AB square whole square plus BC whole square is equal to CA whole square. If it is true, then we say that it is a right angle triangle. Sum of squares of two sides of a triangle is equal to square of hypotenuse side. Hypotenuse side by using Pythagoras theorem. Okay. So here given we have to show that the position vectors 7i plus 10k, comma minus I plus 6j plus 6k and minus 4i plus 9j plus 6k forms the vertices of a right angle triangle. Right angle triangle. Okay. Here given so given points, so therefore we are given OA bar. Sir, OA bar is equals to 7j plus 10k. 10k. Similarly, OB bar. Sir, OB bar is equals to, we have minus I plus 6j plus 6k. Then OC bar, vector OC is equals to, we have minus 4i plus 9j plus 6k plus 6k. So here we need to find AB bar. So that is AB bar, vector AB bar, AB is equal to, sorry, we have to find what AB bar. So therefore AB bar, sir, AB bar is equals to expressing this vector in terms of its position vectors. So that is OB bar minus OA bar. Okay. Again that is equal to OB bar minus OA bar. This minus this. Okay. So we have minus 1 here we don't have any items, therefore 0. So minus 1 minus 0, we have minus I again we have 6 minus 7, we have minus 1j. Again here we have 6 minus 10, we have minus 4k. Similarly, find the magnitude of this. Therefore, magnitude of AB bar is equals to square root of minus 1 square, we have 1 plus minus 1 square, we have again 1 plus minus 4 whole square, we have 16. Again that is equals to, we have square root of 18. Square root of 18. Similarly, find BC bar. So that is BC bar is equal to OC bar minus OB bar. OB bar. Again that is equal to this minus this. Minus 4. Here minus of minus plus minus 4 plus 1. We have minus 3i. Minus 3i. Again. So 9 minus 6. We have plus 3j. Again 6 minus 6, we have 0k. 0k. Again therefore magnitude of BC bar is equal to square root of, we have minus 3 whole square 9 plus minus 3 whole square, we have 9, that is equal to square root of, we have 18. Square root of 18. Next we need to find CA bar. Just remember, in a triangle A, B, C, first find what? AB bar, BC bar, CA bar. AB bar, BC bar, CA bar. So CA bar is equals to OA bar minus OC bar. OC bar. Again, that is equal to this minus this. Okay. We have 0 minus of minus 4. We have plus 4i. Children, what is I term here? 0. So 0 minus of minus 4. We have plus 4. Again, 7j minus 9j. We have 7j minus. We have minus 2j. Minus 2j again. So 10k minus 6k. We have 10 minus 6. We have 4j. 4j. Okay. Again, find magnitude of CA bar. CA bar is equals to magnitude of CA bar is equal to square root of 4 square 16 plus minus 2 whole square. We have 4 again. So 4 square we have 16. Okay. Again, that is equal to square root of 20 plus 16. We have 36. 36. Okay. So now that is C magnitude of CA bar whole square is equal to, so here we have magnitude of AB bar whole square plus magnitude of BC bar whole square. So what is here magnitude of CA bar? We have root 36. That is root 36 whole square is equal to magnitude of AB bar. We have root 18. So that is root 18 whole square plus we have again so root 18 whole square. What is this? We have 36. 2 and root get cancelled. 36 is equal to 18 plus 18. Again 36 is equal to, that is 36. Therefore, the points with position vectors forms a right angle triangle. Dear children, just remember, we have to prove any triangle has a right angle triangle. See that the sum of square of two sides of a triangle is equals to square of hypotenuse side. Generally, see that the sum of any two sides is equal to square of other side. Sum of squares of any sides is equal to square of other side. Then we say that it is a right angle triangle, right? Next, similar question. Find the points A, B, C with position vectors 3i minus 4j minus 4k, 2i minus j plus k and I minus 3j minus 5k forms the vertices of a right angle triangle. Right angle triangle. Okay. So now given OA bar is equals to, we have 3i minus 4j minus 4k. Similarly, vector OB is equals to, we have 2i minus j plus k and OC bar is equals to, we have I minus 3j minus 5k minus 5k. Here we have to show that sum of squares of two sides of a triangle is equal to square of other side. Okay. So therefore we have to find what? AB vector. So that is AB bar is equals to OB bar minus OA bar. Just expressing AB bar in terms of its position vectors. So that again that is equal to OB bar minus OA bar. That is 2 minus 3. We have minus I. Again minus j. Here we have minus of minus 4. Minus 1 minus minus plus, that is we have plus 4 minus 1 plus 4 we have plus 3j. Again children, minus 1 minus 1 minus of minus 4 minus 1 minus 1 plus 4 we have minus 1 plus 4 we have, that is 3. Okay. Next here we have so OB 1 minus of minus plus 1 plus 4 we have plus 5k. Similarly find that is magnitude of AB bar. Magnitude of AB bar that is equal to square root of 1 square 1, 3 square 9 plus we have 5 square 25 again that is equal to square root of 10 plus 25 we have 35. Okay, again we need to find BC bar. So BC vector BC bar is equals to we have OC bar minus OB bar. Okay, again that is equals to we have OC, this minus this 1 minus 2 we have minus I, again the minus 3 minus of minus 1 we have plus 1, so that is minus 3 plus 1 we have minus 2j. Again we have minus 5 minus 1 that is minus 6. Okay, again that is we need to find magnitude of BC bar that is equal to square root of minus 1 whole square we have 1 plus minus 2 whole square we have 4, again plus minus 6 whole square we have 36, again that is equal to square root of 41. Next we need to find CA bar. Okay, is equals to OA bar minus OC bar. Again that is equals to this minus this OA. Okay, this minus this 3 minus 1 we have 2i. Again minus 4 here minus of minus becomes plus minus 4 plus 3 we have minus j. Again this minus this 4 minus minus of minus 5 we have plus 5 minus 4 plus 5 we have 1k. Again so we need to find magnitude of CA bar that is equal to square root of 2 square 4 1 square 1 plus 1 square 1 that is equal to we have 6 root 6. Okay, now check out. So here sum of squares of these two sides is equal to this side, therefore that is magnitude of BC whole square is equal to that is magnitude of AB whole square plus magnitude of CA whole square. Okay, that is what is this magnitude of BC square? We have root 41, so that is root 41 whole square is equal to we have root 35 whole square plus this value we have root 6 whole square. Okay, that is equal to 41 is equal to 35 plus 6, therefore 41 is equal to we have 41. Therefore the points A, B, C forms a vertices of a right angle triangle. Okay, thank you children.